Okay, so this video is for section 8.4, and we are going to be testing the difference between population proportions of samples. So what we're going to do is we are going to use this to test our difference between P1 and P2. So we have a couple of conditions. The first one is that the samples have to be randomly selected, the samples have to be independent, and then you have to make sure that the sample is large enough to use our normal distribution. So our check for that, again, we're going to be using 5, but in this case, since I have two different P values, because I have two different samples, we have 4 checks instead of just 2 checks. So we have a couple of new formulas. So the first new formula that I want to draw your attention to is our weighted estimate, which is shown here, represented by P bar. And we are going to use P bar to determine what Q bar is. So the relationship between P and Q is still the same. P plus Q has to equal 1. So if you know P bar, you can then find the Q bar. Okay, so we have our test statistic in this case is going to be P hat sub 1 minus P hat sub 2. And our standardized test statistic is going to be represented by the following formula. P bar, we're going to use this formula. And then as I just mentioned, Q bar is 1 minus P bar. And then again, remember when you are doing these problems to check to make sure that these are at least 5. And all of the examples that we're going to do today, they all work. So you don't have to worry about checking those. Okay, so here are our steps. First, we're going to verify that our samples are random and independent. Find P bar. You're going to find your, you're going to find your claim and then identify if the claim is the null or the alternative hypothesis. What level of significance are you looking at for this test? From your significance level and whether or not it's right-tailed, two-tailed, or left-tailed, you're going to find your critical values, and then you're going to determine your rejection region. And you can do this in the book, or you can also use your calculator. And then from there, you're going to find your standardized test statistic using the following formula. Next, you're going to make a decision to reject or fail to reject, and then you're going to interpret that decision in the context of your original claim. Okay, so let's go ahead and get started. So the first thing I'm going to do is I'm going to read through the example and then I'm going to organize my thoughts. So we have a study of 150 occupants in passenger cars and 200 randomly selected occupants in pickup trucks. Okay, so I'm going to say number 1 is going to be passenger cars. And then number 2 is going to be pickups. Okay. Now that I have that, I'm going to use the rest of the information in this problem to organize my thoughts before I get started, because that just helps me. Okay, so we have 150 passenger people. We have P hat sub 1, which is 0.86. That's backwards. Okay. All right, now we're going to calculate x sub 1. Okay, so to calculate x sub 1, what we're going to do is we're going to multiply n1 times p hat sub 1, which in this case is going to be 150 times 0.86, which is giving me a total of 129. So that means of the 150 people that they surveyed, 129 of them were wearing their seatbelts. All right, so now with our pickup trucks, we have n sub 2 is 200. In this case, p hat sub 2 is 0.86. So x sub 2 is going to be n sub 2 times p hat sub 2, which is 200 times 0.86. And if I do that, I'm going to get 148. Okay, so our significance level in this case is 0.10, and we are trying to figure out if the proportion of occupants that wear seatbelts is the same for passenger cars and pickup trucks. Okay, so what they are telling me is they're claiming that P1 should equal P2, and that is going to be my null. So then the complement to that statement is going to be that P1 does not equal P2. And that's going to be my alternative. All right. So with an alpha level of 0.1, and this is a two-tailed test, I can find my critical value. And my critical value, there's actually two of them because it's two-tailed, is going to be plus or minus 1.645. So that's telling me that this looks like this. Okay, and I've got two rejection regions, less than 1.645 and more than 1.645. Okay, so the next thing that I'm going to do is I'm going to find P bar. All right, so here's my formula. Let's go ahead and plug in. And I'm going to get this. All right, which means I can find Q bar. All right. So let's go ahead and write down the formula for our standardized test statistic. Z, not a T. Okay. Okay, so P hat sub 1 minus P hat sub 2 minus P1 minus P2, all divided by the square root of P bar, Q bar, all right, there we go. Okay, so let's go ahead and plug in. So P hat sub 1 is 0.86 minus P hat sub 2 is 0.74. We are assuming that this is 0, so minus 0. So 0.791 times 0.209, 1 divided by 150 plus 1 divided by 200. All right, so if we do that, we will get a Z value of 2.73. Okay, so are we rejecting? Let's look. All right, so my critical value was negative 1.645 and 1.645. All right, and I got for my test statistic 2.73. So is that in the rejection region? Yep, it is. Okay, so let's write our sentence. Let me scroll down. Oh, I did not mean to do that. A little bit far. Okay, so we are going to reject. There is not sufficient evidence to support the claim that the proportion of occupants who wear seatbelts is the same for passenger cars and pickup trucks. Okay. All right, so we have another example, and I actually want you to pause and try this one. Okay, did you try it? I hope so. Okay, so in this case, we have a medical research team, and they are trying to determine the effectiveness of their cholesterol reducing medication. So at the end of the study, they had 4,700 participants take the medication, and 301 of those died from heart disease, and then 4,300 of the control group, the placebo group, 357 of them died from heart disease, and we have an alpha level of 0.01. So we are trying to figure out if the death rate due to heart disease is lower for those who took the medication than for those who took the placebo. Okay, so we have two groups, and group number one, I'm going to call them meds. And then group number two, I'm going to call them placebo. Okay, so let's organize our information. So in this case, we have N1 is 4,700. They gave me X1. That is 301. So we can find our proportion by doing 301 over 4,700, which is going to give me 0.064. All right, then we have our placebo group, and there were total in that group 4,300. And X1, there were X2, there were 357. Okay, and then we can find P hat sub 2. So we're going to do 357 divided by 4,300, which is going to give me 0.083. Okay, so let's see. We are trying to figure out if the death rate due to heart disease is lower for our people that took the drug. So our claim is P1 less than P2. This is our alternative hypothesis. And there's our null. So this is telling me that I've got a left-tailed test. So if I have a left-tailed test and I have a significance level of 1%, that is going to give me a critical value of negative 2.33. which means my rejection region is anything less than that. Okay. So let's go ahead and find p-bar. And remember, we don't have to perform our checks because I told you all these examples work, but in real life, you would want to perform the checks. Okay, so p-bar is x1 plus x2 divided by n1 plus n2, which is, okay, 301 plus 357 over 4,700, 4,300. Okay, so that is going to give me a p-bar value of 0.0731. Which means my q-bar, which is 1 minus p-bar, is going to be 0.9269. Okay, I'm so paranoid that I did the same thing on the last example. Did I put the wrong numbers? Oh, no, I didn't. Okay, good. Whew. Okay. All right, so now we have p-bar, all right, so now we got to find z. Okay, so z equals p hat sub 1 minus p hat sub 2 minus p1 minus p2. If you hear random meowing, it's the cat. The cat thinks it's time to eat. But I keep trying to tell the cat it's not even 4 o'clock yet. Square root p bar q bar square root. Nope, not square root. So I always like to write my formulas down, as you know. Helps me keep organized. And I need all the help I can get. Okay, so we have 0.064 minus 0.08883 minus 0 over square root of, let me get myself more room. Okay. P bar, oh, I should write it, shouldn't I? Yeah. 0.07, that's a 7, times 0.9269, 1 over 4,700 plus, I ran out of room. This is still in my denominator. Just ran out of room. Okay, so if I do all that, I'm going to get a z value of about 3.46. Okay, so that being the case, is that in my rejection region? Oh, and this is negative 3.46. So is this, oh my goodness. Okay. Negative, okay. I'm gonna go back to that. All right, so the question is that my rejection region? And yes, it is. It definitely is. Bam, it's right there. Okay, so let me scroll back down. Okay, so I'm gonna give myself a little bit more room. So we're gonna reject the null. So there is enough evidence to support the claim that the death rate due to heart disease is lower for people that took the drug, people that took the medicine, people that. Okay, so the next thing that we're going to do is we're going to learn how to do all of this in our calculator. Yay! Okay, so our calculator steps. So first you're going to hit stat, and then you're going to go to tests, and then you're going to go to prop Z test, because that's a Z. Okay, so some things to keep in mind when you're doing this, you still need to know what kind of claim you have. Okay, so we have a random sample of 7,000 male students. I'm going to call that N1. 1,162 of them smoke, so that's going to be X1. One cigar in the last 30 days. We have 7,489 female students, so that's going to be N2. 539 of them smoked, so that's going to be X2. Our alpha level is 0.05. So we're trying to figure out if male student smoking is greater than the proportion of female students. So in this case, my claim, my claim is the males greater than the females. And that's going to be my alternative, which means my null is going to be less than or equal to. Okay, so the reason why it's always important to do that is because one, it helps you write your summarizing sentence, and two, you need to figure out if it's left-tailed or right-tailed. So in this case, it's right-tailed. And right-tailed with a significance level of 5% is going to give me a z-score of 1.64. So that tells me anything to the right of 1.64 is in my rejection region. Okay, so let's go ahead and hit these buttons on the calculator, and you'll notice it gives you a place to type in your N and your X values respectively. And make sure that you double check everything and double check your alternative hypothesis, because you need to make sure you select that. So if you do that, you are going to get a Z test statistic as 17. All right, so is that in my rejection region? Oh, yeah, it's totally in my rejection region. So we're going to reject the null. Okay, so there is enough evidence to support the claim that the proportion of male students that smoke is greater than the proportion of female students. So let's type that out. There is enough evidence to support the claim that the proportion of male students who smoke cigars is greater than the proportion of female students. Okay. All right, we have one more thing that we're going to do, and that involves finding the confidence interval for the difference in our proportions. So we're also going to do this in the calculator. So we're still going to go to stats, and then you're going to go over to tests, and this time you're going to select to prop Z int. Okay. So just like before, you're going to type everything in, make sure your confidence level is 0.98 in this case. And then once you do that, you are going to get 0.04715 and 0.12785. Okay, so what I could then say is with 98% confidence, the difference in P1 minus P2 is between I want to copy and paste this so I don't have to retype it. All right, and done.